Welcome. We have a collision problem whereby we have a tennis 40 grams, 25 meter per second, force 8 newtons, contact for 0.2 seconds. And let's get the statistics. Let's get the stats right. We have 40 grams, so that's our mass is 40 grams. And we know according to SI unit, we need to have it in kilograms. So it's multiplied by 1 kilogram over 1,000 gram, and then that means the grams cancels, and then we have 40 kilogram divided by 1,000. So that means it's going to give us 0. Let's use a calculator. 40 divided by 1,000, 0.04. So 0.04 kilogram. And then from there we have the wall, we have the ball that goes to the wall, velocity there, that's 25 meter per second. And then from there the ball bounces back. Final velocity we don't know yet. So the mass of the gram is 40 gram on each ball. It's a symbol that goes and comes back, and that's the wall that we have. And then from there, okay, there's 0.04 kilograms. So let us do 1.1 where to calculate impulse of the wall on the ball. So mass is 0.04 kilogram. Initial velocity, that's 25 meter per second, and we have final velocity that we do not know, and we need to get the compass right. We take it as positive, and left we're going to take it as negative. So whenever we're dealing with vertical components, we know our directions. Right is positive, left is negative. So first net that's 8 newtons, and then change in time, that's 0.2 second. Okay, what else do we have? And then impulse. Let's look at the equation of impulse. The impulse there is force net is equals to change in momentum. Okay, we have force net times change in momentum. So we have change in momentum, okay, is equals to force net times time. It's going to be force net multiplied by time. So force times time, that's the meaning of impulse. So impulse has two equations. So impulse is the first is change in momentum, that's impulse, and the other part is also force multiplied by change in time, contact time actually. So force multiplied by contact time, which is change in time, and then that's also impulse. So depending on how or what information we have. So we have force and change in time, so we use the right hand side of the impulse. So impulse is going to be force net multiplied by the change in time. So change in time, so that's the equation. Now let us substitute. Our force net is 8 newtons and our change in time is 0.2 seconds. So that gives us 8 multiplied by 0.2 is 1.6. So it's 1.6, that's Newton dot second. Okay, so that's the unit for impulse. So impulse has two units. Okay, it has the momentum, okay, change in momentum, and then that's impulse there. So calculate the change in momentum. Change in momentum is impulse, that's 1.6. so we can just change the name of the use, MV, so that's kilogram meter per second. So that's kilogram meter per second. So depending on which equation you use different units, meaning the same thing. So give the rate of change of momentum of the ball. Rate of change in momentum, so force net is equals to force net multiplied by change in time. That's equals to change, not change in time, change in momentum actually. So that means force net multiplied by change in time is going to be change in momentum. So force net is going to be when they say rate of, it means we divide by time, so divide by change in time there. So that means there we have that divide by change in time, so that gives change in time, and that particular means that that's the change of momentum. That's 1.3. And then let's find the change in momentum. 1.6 divided by change in time 0.2, it gives us 8. So rate of change in momentum is the force-mate. So that's what we have realized. That's 1.3. And we have to go to the next one, which is 1.4, where it says calculate the velocity at which the ball bounces off the wall. So the velocity, final velocity, we don't know. That's what we need to calculate right now. So change in momentum is going to be momentum final minus momentum initial. So momentum is mass, velocity initial, no, it's actually velocity final minus mass times velocity initial. So that we factor the f, the mass actually, we factor m, so it's going to be final minus velocity initial. So we come in and we check as it goes, there's right, so change in momentum is left. So remember, change in momentum we already have is 1.6, so because it's going to the opposite direction, it's going to be left. Alright, that one that's going to be left, supposed to be negative, so that's going to be 1.6. And then we know that our mass there, that's our equation, our mass is 0.4, our initial velocity is 25 positive, and then we have 0.04, and then our final velocity we don't know, minus our initial is 25 is equals to 1.6. So we divide both sides by 0.04 and by that by 0.04, so that cancels that. So we have v final minus 25 meter per second, that will give us 1.6 divided by 0.04. So once again we use a calculator to find, so that means our final velocity is going to be negative 1.6 divided by 0.04, it gives us negative 40. So it's going to be negative 40. We take 25 to the right, that becomes positive, so that's going to be final velocity. Negative 40 plus 25 is negative 15. So the ball goes back negative 15 meter per second on the opposite direction. So that's our final. So it's 15 meter per second to the left. Okay, left. That's our final answer. Thank you so much for watching, and don't forget to follow or subscribe, and if you have any comment, please leave below. I'll be willing to come back to you. And you're just here with tutor Black Adam. Don't forget to follow or subscribe, much appreciated, and continue to watch more physics problems on this channel.